Hello everybody, welcome into another lesson. So today we're going to talk about what's called the discriminant. Well, first here you notice off to the right I've rewritten the quadratic formula from yesterday's lesson. You have x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. That's called the quadratic formula again. Well, the idea is here we can use what's called the discriminant to not just solve the equation, but to tell if it's going to have two real solutions, one real solution, or no real solution. The discriminant is this portion under the radicand of the quadratic equation. It's just that b squared minus 4ac portion. That's called the discriminant. The reason it's called that is because it discriminates. It discriminates in a way that tells you how many real solutions you're going to have. So if b squared minus 4ac, if you come out with a positive number greater than 0, a positive number, you're going to have two real solutions. If you have b squared minus 4ac equal to 0, you'll have one real solution because you'll just get 0 in the square root. And then if b squared minus 4ac is less than 0, or gives you a negative number, in other words, you're going to have no real solution because the square root of a negative number doesn't give you a real number result. So today we're just going to find the value of the discriminant and see how many real solutions it would have. We're not going to actually solve the equation. We're just going to deal with the discriminant. So let's go ahead with our first problem here. We have x squared minus 5x plus 4 is equal to 0. Again, we're not going to input the whole quadratic formula today. We're just going to solve for the discriminant, which is b squared minus 4ac. So your b coefficient is negative 5, so you would take negative 5 to the second power minus 4 times your a, which is going to be 1, times your c, which is 4. So now when we simplify this, negative 5 to the second, that's positive 25. Then we have negative 4 times 1, which is negative 4, times positive 4, it's negative 16. We have 25 minus 16, which gives you 9, which is a positive number. And since the discriminant is positive, you have two real solutions. You would have two real solutions. It would be something plus and minus the square root of 9 over 2a. So yes, you have two real solutions since your discriminant gives you a positive value. So that's all we're going to do today is see how many solutions does the equation have. Okay, how about this one? We have r squared minus 3r plus 9 is equal to 0. So r squared minus 3r plus 9 is equal to 0. Well, let's do the discriminant again. The discriminant is just the b squared minus 4ac. So your b coefficient is negative 3. So you'd take negative 3 to the second power minus 4 times your a coefficient of 1 times your c coefficient of 9. Which, simplifying this, negative 3 to the second, that's positive 9. Then you have negative 4 times 1, which is negative 4, times 9 is negative 36. So you would have 9 minus 36. Well, that's going to give you negative 27 for your discriminant, which we can't take the square root of a negative number and get a real number result. So you're going to write this as no real solution. There's no real solution to this. Now you don't, especially now that we're at the end of Algebra 1, because we got one more lesson left after today in Algebra 1, and that's it for it. It's time to stop just simply using Algebra 1 thinking. You need to start thinking in higher level maths. So you don't want to just say no solution. That means there's no solution at all in the imaginary numbers either, or anything like that. but there's just no real solution. We'll get into more of that stuff as we get into Algebra 2, but say no real solution. That's what you'd want to say. Okay. How about the next one? We have n squared minus 16n plus 64. That's going to be equal to 0. So n squared minus 16n plus 64 is equal to 0. Well, take your discriminant, the b squared minus 4ac. Your b coefficient is going to be negative 16 to the second power minus 4 times your a coefficient of 1 times your c coefficient of 64. Which, when we simplify this, you're going to end up getting negative 16 to the second. That's positive 256. Alright, then you have negative 4 times 1. That's negative 4 times 64. That's negative 256. And lo and behold, you get exactly 0. If you get exactly 0, there is one real solution. So you think about it, the square root of 0 is just that, it's 0. It's neither positive nor negative, so whether you add or subtract 0 to the rest of the quadratic formula is irrelevant. You'll just get one real solution. So that's how many you would have for that. Okay, let's do the next one here. Let's see, we got 2z squared plus 5z minus 3. That's going to equal 0. So we have 2z squared plus 5z minus 3 equals 0. So let's do our discriminant here, which is b squared minus 4ac. Your b coefficient is 5, so you'll take 5 to the second power minus 4 times your a coefficient of 2 times your c coefficient of negative 3. Which now, when we simplify this, 5 to the second, that's 25. Then we have negative 4 times 2, that's negative 8, times negative 3, that's positive 24. 25 plus 24 is 49. You got a positive number for your discriminant, so there are two real solutions to this. You'll have two real solutions. That would be your answer. Alright, let's see. 9y squared minus 12y plus 4 is equal to 0. Okay, so we have 9y squared minus 12y plus 4 equals 0. So again, do your discriminant of that b squared minus 4ac. Your b coefficient is negative 12, so you're going to take that negative 12 to the second power minus 4 times your a coefficient of 9 times your c coefficient of 4. Well, let's see, let's simplify this. Negative 12 to the second turns into positive 144. Now you have negative 4 times 9, which is negative 36 times 4. That's negative 144. So you have 144 minus 144, which is 0. That means you have one real solution to this problem. There is one real solution. And that would be your answer to how many real solutions there are. There's one. Alright, I got 1, 2, 3, 4, 5 more. I got 5 more, then we're done. So let's see. we have 3t squared minus 4t plus 3 equal to 0. Alright, so 3t squared minus 4t plus 3 is equal to 0. So let's do the discriminant. See, our b coefficient is negative 4, so this is going to be negative 4 to the second power minus 4 times your a coefficient of positive 3 times your c coefficient also positive 3. Well, let's simplify this here. Negative 4 to the second power, that's positive 16. Then you have negative 4 times 3, which is negative 12, times 3 is negative 36, so you got 16 minus 36. That's going to give you negative 20. Well, the discriminant's negative in this case, so we actually have no real solution. Since the discriminant is negative, you get no real solution to this problem. All right. What do we got here? Let's see. 4m squared. We have 4m squared plus 20m plus 25 is equal to 0. Alright, so we've been given 4m squared plus 20m plus 25 equals 0. So again, let's do the discriminant, the b squared minus 4ac. So the b coefficient is 20, so that's going to start out as 20 squared minus 4 times your a coefficient of 4 times your c coefficient of 25. So let's go ahead and simplify this. 20 squared, that's 400. Alright, then negative 4 times negative 4, negative 4 times positive 4 is negative 16 times 25. That's going to also be negative 400. So now you have 400 minus 400. That gives you 0. Since it's equal to 0, you have one real solution to this problem. So to this particular equation, you have one real solution. Alright, 3a squared minus 2a minus 6 equals 0. So we have 3a squared minus 2a minus 6 equals 0. So let's do the discriminant formula again of b squared minus 4ac. Your b coefficient is going to be negative 2, so you'll take that negative 2 to the second power minus the 4 times your a coefficient of 3 times the c coefficient of negative 6, which we simplify this. Negative 2 to the second is positive 4. Then negative 4 times 3, well, that's going to be negative 12 times negative 6, that's positive 72. 4 plus 72 equals 76. You got a positive number, so there are two real solutions to this problem. So therefore, this problem has two real solutions. Alright, I got two more problems. Let's see. We have negative 5b squared plus b plus 1 is equal to 0. So we have negative 5b squared plus b plus 1 is equal to 0. Well, let's go ahead and do the discriminant again. The b coefficient is 1, so that's going to start out as 1 to the second power minus 4 times your a coefficient of negative 5 times your c coefficient of positive 1. Well, 1 to the second, that's just 1. Negative 4 times negative 5, that's positive 20, times 1 is positive 20. So now you have 1 plus 20, which would equal 21. So you have a positive discriminant, that means you have two real solutions. So there are two real solutions to this particular equation. All right, one last problem. Let's see. We have negative 4q squared plus 3q minus 2 equal to 0. So negative 4q squared plus 3q minus 2 equals 0. So let's do our discriminant again of b squared minus 4ac. Now your b coefficient is going to be 3, so you'll take the start as 3 to the second power minus 4 times your a coefficient of negative 4 times your c coefficient of negative 2. Simplify this now. 3 to the second power, well, that's going to be 9. Now you have negative 4 times negative 4, well, that's positive 16 times negative 2, well, that'd be minus 32. So you have 9 minus 32, that's going to give you negative 23. And the discriminant's negative, so in other words, we have no real solution to this problem. So there is no real solution to this. So that's it for the discriminant. And I can formally say at this point I've taught you everything I can teach you in Algebra 1. We have one more lesson left of Algebra 1, and what that's going to entail is you're given some quadratic equations, and you got to decide which method is best to solve it. Because after Algebra 1 here, once you get to Algebra 2, it's going to be assumed you know how to solve those equations, that you know all the methods already, and that you can pick out a method that works. But first, before we do the equations, I'll lay out a good strategy for you of how to proceed with an equation. So that's it for this lesson. I hope everyone has a good night. Take care.